Which direction did the bullet come from? All right, so let's go right here.
Lucky bastard. Jesus!
Immediately, you know that the bullet came from his left, right? And then all of a sudden, the indentation appears. And you saw the initial jerk in that direction. I mean, the bullet was moving. Acceleration is in the direction of the force, so the initial jerk is in that direction. It's beautifully done. So by looking at the initial jerk, direction of the initial jerk, initial acceleration, you know that the force causing that acceleration is in the same direction. So that tells you about the direction of the bullet. All right, I'm not sure how many of you guys seen this movie. Those of you guys who have, give yourselves 5 points for it. So it's Private Ryan.
Jesus! Come on, lucky bastard.
I don't know why. I can't stand the sight of blood. And what's weird about it is my dad is a medical doctor. My mom is a nurse. What that means is I should be perfectly comfortable with the sight of blood. I should be comfortable swimming in it. Forget about looking at it. But I simply can't stand it. So I can't really watch these slashers. For whatever the reason, though, the war movies I'm a big fan of. All right. So if there's violence, the violence is kind of like what you just saw there. It's brief. By the time you notice it, it's too late, and they move on to something else. And you know, it's suspenseful, and then obviously you get into it. You get into the adventure of it. Except this movie was different. When the Private Ryan came out, the first 20 minutes to half hour of this movie was set to be so realistic that even the war veterans were having flashbacks. It was that bad. In fact, one of my yeah, go ahead.
I just spoke to a veteran who's actually been in combat, and he said the same exact thing about this movie and Hamburger Hill too.
100%. Give yourself 5 points. A friend of mine, this guy was a philosophy professor, and he actually volunteered twice for Vietnam. He said, "Ken, you got." He said the first half hour of the movie, he said, as realistic as it gets. He said it's a complete clusterfuck. All right, those are his terms. He said it's just so incredible. He said you got to go see it if you want to see something anywhere near as realistic as what a real battle experience is. He said the first half hour is exactly what it is. He said you don't know what's going on, and you can't hear anything, you can't see anything, and then there's this mess all over the place. Except the first half hour of the movie, from what I read, was just so gruesome. It's so bloody and so gruesome. I didn't think I was going to be able to handle it. All right. I mean, Hamburger Hill, I've seen it. The violence, when it happens real fast. But this thing is like, it's supposed to be really, really gruesome. So I wasn't sure. So I thought about it. I thought about maybe I should just skip the first half hour and then walk in a half hour late. So I could make up my mind. So I thought about it for about a month. So I said, okay, I'm just going to go to the movie theater. And then I was going to check myself into a bar and get drunk. And then when I felt brave enough, just walk in and watch the entire movie. Anyway, so I watched the entire movie. Let me put it this way, from beginning to end. The first half hour was bad. It was gruesome. Except I got really distracted because of the accuracy of physics. Accuracy of physics was unbelievably on point. It was so incredibly well done that I couldn't even focus on the violence properly. I could see the guy in the background running around with his intestines sticking out. He's just trying to push him back. And it was bloody. It was, I mean, the gore was all over the place. But the physics was just so incredibly accurate. I had to go watch the movie again just for the story. All right, so in terms of the accuracy of the physics, the stuff that I'm going to show you, number one, if you're squeamish like me, you're not going to see any blood. Okay, so I'm picking a scene on purpose. It's almost like a comic strip movie violence. So there's going to be violence, but there's not going to be blood. All right, so this is the scene. All right, so you're looking at this. Going to be a complete miscommunication. Two different languages. All right, so this is the guy I want you to focus on. All right, you don't have a choice because camera is going to focus on that guy. All right, so notice that other people are going down. Okay, so the shooting is still going on. You can see that the bullets are going through his body. The parts of flesh is flying out. The clothing is flying out. Eventually, it stopped. Okay. One of the things that I want you to notice is the people who got shot at, they just dropped. And this guy did not even acknowledge that he was just getting shot at. All right. Despite the fact that this guy probably took about 20 bullets to his body. He's not moving at all. Okay. So in the video games and most of the movies, I want you to notice that when someone gets shot at, when someone is actually hit, they kind of acknowledge the body jerks in that direction. Or if it's somewhat exaggerated, like in the video games, you will see people actually flying in the direction of the bullet. Here, there's no reaction to it. This guy didn't move. He didn't move at all. He didn't even move an inch. He didn't move a muscle. In fact, go back. When the movie starts. All right, notice that these guys are going to go down. All right, and none of these people fly in the direction of the bullet. He just dropped. This guy didn't even move. Yeah, he's got a backpack, but forget that. His body does not even acknowledge the fact that he's taking all these bullets to the body. All right. In the movies, you would see a little bit of a reaction, or quite a bit of a reaction when they get shot at. This guy didn't move at all. So is this realistic? Spielberg is the director, obviously. All right. And they have probably had footage like this, probably about, I don't know, 3-4 hours of footage that they probably didn't use. But for whatever the reason, they decided to leave this in the movie. All right, so is this really what happens in real life? I got news for you guys. This is pretty damn close to what should happen in real life from a close range combat, just like that. The reason is because these bullets are going so fast, like 1,000 miles per hour, even faster than that. Your body is extremely massive, all right? It's got a large tendency to retain this initial motion, so it's not going to want to move unless there's a force acting on it. In this case, there's a force acting on it, but the duration of the force is just a fraction of a second. So it's not large enough to overcome your inertia. What that means is, you guys know the analogy, right? The heavy dishes on a tabletop, and then you got the tablecloth, and you pull it really hard. What happens to the dishes? Nothing. They don't move. Same thing happens to the body. All right. So normally, what happens when somebody gets shot at like that? It's if you can stop the heart, the person is just going to end up dropping on their knees and fall down. All right. Unless the bullet makes contact with one of the major bones in your body, you're not going to see much of a reaction in reality. Mythbusters actually tested this by using pig carcasses. And they end up using guns, from handguns to military-grade weapons, rifles or whatever. With bigger bullets, these carcasses, they were hanging from hanging from a rope, basically. Carcasses end up moving when they got hit, but their motions were less than an inch. You could barely see the carcasses sway back and forth. So realistically, this is what you would expect to see. Why is this important? It's important. There are two reasons for it. Number one, it's a safety thing. A lot of the times people expect to see when there's a mass shooting or whatever, it's very difficult to make that connection, make that leap. I don't know, like 10 years ago, somebody showed up with weapons over at NIU, walked into a classroom and started shooting. There were almost 100 students in that mega classroom. Initial reaction of students was laughter, one of laughter. They thought that was a practical joke, okay, because they could hear the pop, and then the timing was off. They didn't, so you would normally expect someone who's shot at to fly in the direction of the bullet, so they didn't see that. Instructor went down real fast, so this guy turns around and starts shooting at students in general. Once again, the initial reaction was laughter. Eventually, they saw people just dropping down and bleeding, so there was mass panic. Quite a few students ended up getting killed. I don't remember how many, but that was a traumatic event. All right, so basically, you're not going to see people fly. If you see a gun, take measures, obviously, protect yourself and get out or attack. Or find a way to resolve that issue. All right, another thing is, human body does not quite react the same way as a ball does. Kennedy getting hit. All right, so evidently you would expect a second shooter, and you almost could see it. There was an explosion. So what happened was the bullet ended up entering from the back of the head, traveled through the brain. The brain is still alive, so it's just activating all these nerves, and the nerves are just convulsing all these muscles all over the place. There was the skull ended up exploding forward, so you end up seeing that flash. And the body, the muscles just convulse in the backward direction. All right, so notice that number one, you expect to see some motion in the direction of the force. You don't see that when it's going through the flash. So that's something that was not visible, because this thing happens so fast. It just goes through the skull, and then it's not like hitting a helmet. The skull is going to give. So it went through the brain. There was an explosion, and the brain was still alive. So it caused all sorts of convulsions in the muscles, and then the body jerked in a weird sort of way. So that's what happened. All right. So it doesn't quite follow the physics of hitting a bomb. So that's a little bit different. All right. So let's take this one step further. When an object is falling, okay, so I'm just dropping this bomb. Is gravity a force? What are you going to say? You will say, of course it's a force, because it causes acceleration, guys. You cannot feel gravity. You cannot see gravity. You cannot taste it. If gravity is the only force acting on you, literally, if gravity is the only force acting on you, you will not even feel gravity. You will feel weightless. Right, so how do we know that gravity is a force? It is a force because, by definition, because what a force does is acceleration. The falling ball accelerates in the direction of the force, which means that the gravity is a force because it causes falling objects to accelerate. That's it. So the next question is, does gravity extend all the way out to the moon? Of course it does. What would happen if it didn't? If gravity didn't extend all the way out to the moon would have gone in a straight line at constant speed. We would not have the moon. Immediately, we got answers to our questions. All right, so Newton's obsession was, well, if Apple falls because of gravity, and he knows gravity is a force at that point because it causes acceleration, he wants to know, why doesn't the moon also fall from the sky? But at the same time, he knows that gravity extends all the way out to the moon, right? How does he know that the gravity extends all the way out to the moon? Because if it didn't, what would happen? It would have gone in a straight line at a constant speed. And all of a sudden, he's curious. His curiosity is, he knows the apple falls because of gravity, and he also knows that gravity extends all the way out to the moon. If so, his question is, why doesn't the moon also fall from the sky? All right, so pick out your answers and put it in the chat. All right, I see a lot of D's, so D is the best answer, so that's 5 points for that one. So how do we know that gravity extends all the way out to the moon? There are two ways we know it. Okay, so this is also your next test question, because it's intriguing enough and interesting enough. All right, there are two ways we know. Number one, if gravity didn't extend all the way out to the moon would have gone in a straight line at a constant speed. The moon moves at a constant speed, but it doesn't move in a straight line. It goes in a circle. It's almost elliptic motion, but let's say it goes in a circle, which means that its acceleration is directed towards the center. It's centripetal acceleration. Remember, it's directed towards the center, and then the force points in the same direction. So, which means that this motion is happening because of gravity. The moon is accelerating towards the center of the circle. At the center of the circle, you have the Earth, and then the force is pointing towards the center of the circle where the Earth is. So whatever this force is generated by the Earth itself. All right, so this is the force of gravity, extending all the way out to the moon. All right, definitely give yourself 5 points. Easy, the best answer. So the car is moving at a constant speed, but it's accelerating, which means that there's enough force acting on the car. All right, give yourself 5 points. Now, here's the question. If gravity extends all the way out to the moon, how do you explain the fact that the astronauts appear weightless in space then? How could that be? So weight is something that comes, weight is the gravitational force acting on you. All right, so the measure of gravity, the effect of gravity on you is known as your weight. If gravity extends all the way out to the moon, can you be weightless in space?
Astronauts eventually adapt to their balance sensors, giving them confusing and unfamiliar information. After a short time in space, the human body actually forgets how to deal with gravity, and instead learns how to balance and move around without it.
If Newton is correct, if gravity extends all the way out to the moon, you cannot be weightless in space between here and the moon. When you're 180 miles from the surface of the Earth, you cannot be weightless in space. And if you're a conspiracy theorist at this point, you will think to yourself, wait a minute, is this thing completely made up? Or is there a better explanation for it?